learn about methods. Last time we learned what kind of statements we have in Java. So just a quick review, we learned that we can declare variables. We learned that we can give variables some values. We can assign something to them. And we learned that we can do method calls. And so today we're going to learn how to write a method. Okay? So let's just dive right in and not mistype anything at all. So to declare a method, what you need to do is you need to be inside of a class. So we're already inside of a class. We have our little test project class, or whatever you have named yours. So we want to be somewhere in these brackets, but not inside any other brackets. So we don't want to put it inside here, okay? You want to put it inside the class. So we're going to make a method down here. Here's the method syntax. Remember, this is a comment. You can type this if you want, if it helps you out. But here's a method syntax. We're going to have the accessor. Let's call it something else. Let's call it access level, I guess. Space. Return type. This isn't quite true. We'll ignore that. We can have. Let's make that one word so as not to confuse people. Method name, parentheses, and then inside here you can have 0 or more parameters. This is an optional thing. And actually, what I think I'll do, no, I'll leave it like that. That's fine. Sometimes when you're writing documentation and something's optional, you put it inside these things, these square brackets. But in most programming languages, that means array of something, an array. So we're not going to do that. I'll just use the ellipses. This isn't quite how a method looks. There's actually one more piece. You might have seen it up here. What's this static doing up here? This is called a modifier. I'll tell you what those are later. Don't worry too much about it right now. So I'm going to write a method. There are 3 access levels in, actually there are 4, but only 3 of them have names. There's public, and for now we will make everything public, just for simplicity. Public means that any class can access this method, which is usually what you want. Sometimes you don't want that, but for the purposes of these videos, we're going to make most of our methods public. Okay, so that's going to be the access level. There's private, where you can only call the method inside that class. So if we wrote this method, we would only be able to call it basically inside this text file. We wouldn't be able to use it in any of our other code. So we don't want that. So public means anything can use it. Private means only this thing can use it. And there's another one, protected, which we'll talk about in another one. But we're going to make it public. And modifiers. We're going to have one modifier called static. I will not explain to you what this is yet. Just trust me, you need this for now. Most of your methods will not have this, but today we're going to use static. And just very briefly, the reason we're using static is because this is static, and we're going to call this method inside here. Anything that's inside these brackets has to be static. So that's why we have it here, but most of the time you will not be using static. The return type of this method, we're going to make an integer, okay, an int. So we're going to call this method, and when the method's done, it's going to replace itself with a number, basically. That's what's going to happen. So now we need a method name. I think our method name should be double me. And we're going to give it just one parameter, and it's going to be an integer. It's going to be some number. Now, I was teaching my friend this stuff, and there's something that kind of confused him a lot, and I didn't really understand why until I kind of connected it in my head. This variable name in your parameter does not have to match the variables that you actually use, and we'll see that in a second. Right now, NetBeans is complaining because this method says it's going to return an integer, but right now it's not returning anything. For right now, we're just going to say return 0. Okay? And so we're going to go in here, int test number equals double me 5. Doesn't really matter what we put in there because it's not going to work anyway. And then we're going to do a system.out.println, which is a method. And we're going to print test number. I did not change the formatting of the thing. Let me go see if I can do that now. Hopefully it won't give me the same error I got last time. Dead time on air is sometimes fun, but usually not. Okay, it's not even bringing up the options. I guess I'm not going to do it. Oh well. Let's run it. So actually, let me actually write it this way. We're going to define our variable, and then we're going to assign it. I think this will just look a little bit more clear. You can combine these two lines, but let's do it like this because I want it to be as simple and as clear as possible. So what we're going to do is we're going to make a new variable with no initial value. Then we're going to give it a value. The value is going to be whatever this method does. Okay, this method's going to give us back a number. And then we're just going to print what we get. Okay, so let's run it. And it should be no surprise that we got 0. So here's what the code is actually doing. Actually, here's what I'm going to do. Come on. Why isn't it letting me do that? Oh, because that's not a line of code. When you declare a variable, it won't let you stop. Don't worry about this right now. I'm going to show you something that's really cool later, but right now it hopefully won't confuse you too much. So this is called a debug view. Whoa, these are all in the wrong place. This guy's going to go over here. Over right there. There we go, that's better. This is called the debug view, and this basically lets you run your program one line at a time, and you can stop wherever you want, like mid-execution. This tool is very useful for obvious reasons. We're going to step through it one line at a time. It shouldn't take long because there's not much code. So right now we're on this this statement, test number equals double me 5. And we can actually see, have I defined a test number? I guess it's not going to show up here. We're going to go to the next line. So now test number is equal to 0. And so now we're on this line. Ignore this red. This red is just where I stopped. But now we're on this green line, system out print line test number. So we're going to, oh, let me start over. I messed up. Let's try it one more time. I stopped in the wrong place. Alright, here's where the code's going to go. So we're going to get to this line. We haven't run this line yet. We've just gotten to it. So now we're going to, what it's actually going to do is it's going to go inside of double me. Because we have a function on the right, it has to evaluate the right-hand side first. Okay? It's an assignment. Remember, when you have something equals something, it's an assignment. So we need something to be on the right, and we need it to be a value. If it's not a value, Java will do whatever it has to do to make it a value. So in this case, it's a method, so Java's going to call that method. So now we're inside this method, and there's only one statement, return 0. So when we hit next, we're going to jump back here to the line we were just at, and I wonder if it will, it's not going to tell me what the return value was. Sometimes it does, but I guess it's not going to do it. So now we're going to go ahead to the next line. So now we've assigned 5 to test number. This is also kind of small, but I can't make it bigger, unfortunately. And test number is 0, because that's what we returned. And now we're on this line, system out print line. If I wanted to, I could even go into that code, and we'll see that it's going to be on this line, and then it's going to be on this line. And I can even go into this line of code, because this is another method that's being called. This is going to jump somewhere else, do some stuff, and then come back to this line. But we're not going to do any of that. We're just going to leave the method. There we go. And now we're at the end of this. We're at the end of our main method, and the program's going to stop. Okay? That's it. We've just written a program that prints 0. Something I probably forgot to note is every Java program will start at its main method. Java is going to look for a method that's called this, that's called main, and it's going to run it. So this is the start of every Java program, this main method right here. So that's why the first line was actually this one. This isn't actually code, it's just you're defining something. This actually does something. So this is the first line I was able to stop at. And so that's how methods work. When we get to a method, we're simply going to jump into it, starting at this bracket here at the top. We're going to run it line by line, and then once the method's over, we're going to return right back to where we were. That's all a method is. It's some code that you jump to, it does stuff, and then you jump back out. Exactly where you left off. But this is a pretty useless method, because it always does the same thing. We're going to make it do something interesting. I called it double me. I could have called it anything, but let's make it kind of do what it's called. We're going to return some number times 2. Now in Java, times is this little star symbol, not the letter x. Okay, some number x2 would actually be a variable name. So we're going to do some number times 2. You don't need the spaces, but I like them. So now if we run this program, what do you think we'll get? Well, we're going to have test number equals, and we're going to call this, we're going to call double me 5. Let's go down here. So this right here, this parameter is going to be 5, because that's what we've passed in. Okay? And we're going to return, since this is 5, we're going to return 5 times 2, which is 10. So when I get here, test number should be 10, and when I print it out, we should see a 10. So let's run the file. 10. Excellent. Let's make another method. Let's make one that's slightly more complicated. We're going to do division. Int. I never remember what they're called. The divisor is the one on the bottom, or is it the one on the top? Nominator. Int denominator. And Eclipse, or not Eclipse, NetBeans is complaining. I'm gonna run out of room. Eclipse is complaining that I don't have a return value, the same thing it did up here. So again, for now, we're gonna return 0. So we're going to get rid of this line of code, this test number equals double 5. We're going to do something a little different. Test number equals division. And we're going to make it, how about 20 and 4. Okay? So what do you think this is going to return? I mean, this is a little bit of a trick question if you're new, because it's actually going to return 0, because we haven't told this method what to do. This is just kind of a placeholder. So if I run it, we're going to get 0 in our little printout. There it is. So let's make this method do something. This is going to be pretty simple. Return nominator divided by, which is just the / denominator. And so now if I run it, this should print out 5, because 20, which is going to go in the first parameter. The order of these parameters matters, in case you didn't pick this up. So when I call this division, the first parameter gets assigned to the first variable here. The second parameter gets assigned to the second variable here. That's how it works. They're in order. So it's going to call division with 20 and 4. So we know that nominator is going to be 20, denominator is going to be 4. We're going to return 20 divided by 4, which is 5. And if I run it, we're going to see a 5. There it is. Now I want to show you something that you might find a little interesting. We're going to do 20 divided by 11. Okay? What do you think it's going to print out? I don't actually know that off the top of my head. Let me get my calculator open right here. We're going to go to scientific mode. 20 divided by 11. I'll get an exact number. It's 1.81 repeating. So let's find out what we get. 20 divided by 11. We get 1. Okay, we didn't get 1.81, or whatever it was. We got just a 1. Now the reason we got a 1 is because these are integers. This int right here, actually it's this one right here. And the integers that we're passing in here, 20 and 11, these are whole numbers. When you have integer types in Java, they can only be whole numbers. So what's actually happening is Java's giving us a 1.8 probably internally, but it needs to return an integer, so it's going to just get rid of the decimal. So basically Java rounds down when it does integer division. Okay, addition, multiplication, and subtraction are no problem because those are all integer safe, but division is not. Okay, when you divide two integers, you're going to lose the remainder. If you want to keep the remainder, well, that requires a different kind of variable. That's what's called a floating point. We just type a float. Float, let's see, let's call it fraction. That's a bad name. Some decimal expansion equals, let's make it 0.0. And to denote that it's a float, you have to put f at the end of the number. I don't know why they did that, but you just need it. Float some decimal expansion equals 0.0. Now what I'm actually going to do, I'm going to comment this out, because we're going to change our function. Oh, why don't I just call this test number, because I'm lazy. Float test number equals 0. Oh, I already defined it. We'll get rid of this line too. Alright, we're going to change our method down here. Instead of returning an int, we're just going to make it return a float. No problem. And instead of taking integers, because this will be integer math, we're going to make these floats as well. So a nominator and a denominator that are both floating points. That's what the float stands for. It means a floating point. A number where the decimal point can move, basically. So now we have test number equals 0. We haven't called our function, though. So we're going to do test number equals division. Now we'll do 20, that's a 10. We'll do 20 divided by 11. And now we should get the 1.81 repeating that we expect. So we'll save it, we'll run it. And there it is, 1.8181819. The reason there is a 9 at the end is obviously because Java's rounding. It can't actually display an infinite number of digits, so it just rounds at some point. And it decided to round right there. So now we've written some methods. Is there anything else we can do with this? Let's see. Let's write a slightly more complicated method. I'll teach you a little bit about recursion. Let's do public static int factorial. And we're going to give it an integer. We're just going to call it n. Okay, we're just going to call it n. And just so you can see everything on one screen, I'll delete this one. We'll keep the division. I just want to keep all my code on one screen. We're going to change these back. Actually, we'll keep those there. We'll just make different things. Int, let's do 5 factorial equals factorial, because we're calling a method, and we'll put 5 in there. And this thing's complaining because it doesn't have a return value. I'm going to go very slowly, because recursion can be confusing if you've never heard of it before. Recursion basically means when a method calls itself. And I'll show you exactly why that's useful. So for those who don't know, let me explain factorial first. Get rid of these. Factorial n returns the my vocabulary is just gone today. Returns the product of every integer from n to 1. So basically factorial 5, e.g. factorial 5 is 5 times 4 times 3 times 2 times 1. Okay, that's what a factorial is. It's whatever number you put, it'll multiply that number by every number under it. So here's how you do it. We only go down to 1. So what we're going to say is every recursive function needs what's called a base case. Basically, it needs a way to stop. Otherwise, it'll infinite loop on itself. The way that a factorial will stop is if we get to 1. Or if we never get to 1, like if it's negative or whatever. So we're going to say if n is less than or equal to 1, return 1. I think the factorial, okay, this is not completely mathematically true because I believe the factorial of 0 is 0, but we're going to return 1 anyway, just to make it simple. So that's our fail case, our base case. That's how this recursion is going to end. If it's not less than or equal to 1, I'll explain ifs later. But hopefully you can understand what this means. If it's not equal to 1, how are we going to do it? We're going to return n times factorial of n minus 1. This is our factorial function. So here's what's going to happen. If I call it up here with factorial 5, I'll actually run through it. You know what? I'm just going to copy this and put it down here so it's out of the way. We're going to call factorial, and 5 is going to be the only parameter. So we're going to jump in here. So n is 5. We're going to run into this line. If n is less than or equal to 1, well, n is 5, so this isn't true. We're just going to skip this line. So instead we're going to run this line. We're going to return n, which is 5, times factorial of, and this n minus 1, this is 4. Same as return factorial 4. Oh wait, sorry, 5 times factorial 4. Okay, that's what this line's going to do the first time. But we have another function here, so we're going to jump into that function where n is 4. 4 is still not less than or equal to 1. We're going to skip this thing. So then we're going to return 4 times whatever this thing is. And this thing's going to just keep propagating. It's going to keep calling itself. And eventually what's going to happen is we're going to get to 1. Okay, so it's going to call it for 3 and then 2. And this is going to call factorial for n equals 1. Then it's going to return 1. Okay, hopefully try to picture like a little picture in your mind. In fact, maybe I can draw a little thing down here. I'm going to draw a little picture and get rid of all these. Here's what's going to happen. Uh, 5 times factorial 4. Get rid of these little stars. 4 times factorial 3, and that is going to say return 3 times factorial 2. And on the next line, return 2 times factorial 1. And because that one is factorial 1, it's just going to return 1 because of this. So we've called all these methods, none of them have completed. We've called the last one where factorial n equals 1. It's going to return 1, so that's going to go up here and replace this. Okay? Then this is going to return 2 times 1, which is just 2. So that's going to go into here. Then this is going to return 3 times 2, which is 6, which is going to go up here. Then this is going to return 4 times 6, which is 24, which is going to go here. And then, so this factorial 5 that we initially called is actually going to return 120, my math, 120? Is that right? 120. So if we run it, and I've done everything correctly, which I hope, we should see, oh, that's not 5 factorial. We should see it returning 120. Perfect. So you can make methods, and inside your method, you can have statements as normal, you can have other methods as normal, and methods can call themselves. And this is sometimes useful if you're finding a factorial of something. There are a lot of other reasons to call a method within itself. But that was kind of a complicated method. I hope you're able to follow along. Maybe if I kind of align these a little better. Messed up on that one. Get rid of that. Okay, they're kind of lined up now. So this return 1 is going to go in here. The return 2 times 1 is going to be this thing. The 3 times 2 is going to be this thing. The 4 times 6 is going to be this thing. And then this is the original factorial return statement that we called the first time we got to this line. I think I can actually show you the stack of what this looks like. I'm going to debug it, and somewhere on my screen, if I... Here we go in the top. That's not it. Is that it? That is it. This thing right here, this is, I believe that's the stack. Let's hit play. This is the stack. So let's see, 1, 2, 3, 4. Oh, I missed it, because n was 1 on the last one. Let me do it one more time. So let me stop it here. 3, 4. Alright, here we go. This stuff up here is the stack. So remember, we were originally in the main method. That's this thing on the bottom. This testproject.main. And it tells you we're on line 12, which is this line. So we're in the middle of calling this factorial statement. Then our first factorial function is right here. And the variables over here... Wait, what? That's not right. Do I have to double click? I have to double click. The first factorial function, n was 5. The second one we called, n was 4. the third one we called, n was 3, and then it was 2, and now we're in this one, the very top thing on the stack, where n is 1. So it's going to return 1. We'll hit return. So that item on the stack goes away, and we're on the next one where the input was 2. So now it's going to return 2 times, and this just returned a 1. So I'll hit next, and now we're on the function where n equals 3. I think you get the idea. This is why it's called a stack, because you put things on it, and the only way something can come off is if everything above it has come off first. So that's why recursive functions work, because we're calling these within each other, but they have to wait until each other finishes, if that makes sense. So we went all the way down this chain right here, we went all the way down this chain of method calls. This one returned because it hit the base case. So then we jump back to where we were in the previous n equals 2 factorial, and then we jump back and jump back and jump back. I hope that this was not too confusing. Probably talking about recursion when you're learning methods, not the best idea. But I wanted to show you that you can make methods do anything. You can make methods do anything, and this is the power of programming languages. In olden days, before my time actually, functional programming language, I'll go ahead and stop this debugger, I'll just hit play I guess. In old times, functional programming language was, or functional programming it was called, was the main way to write code. Just like I've done here, where you have a main method and you have a bunch of functions. That's how people coded before. But what makes Java so good, and other what are called object-oriented languages, what makes Java and other languages so good is you're not just calling functions, you can have objects that store data, but objects themselves can have their own methods like that they own. Okay, so objects can have methods. You don't have to just declare a method, somewhere. You can define a method inside an object, and then when you call the method, you have to call it with that object. And we're going to do that in the next video where we learn how to make objects. And objects are really what make Java really easy to program in. It makes it so easy to program in. If you thought this stuff was slow and cumbersome, it's because it was. Nobody programs like this, okay? We all program using objects in Java. And that's